In this video, we will discuss chemical reactions in solution. Most of the chemical reactions we conduct are done in solutions because solutions allow much higher possibility for atoms to interact with each other on the molecular level. If you compare mixing two solids, a solid substance will have atoms arranged in a closed packing like this. So only the atoms on the surface will be exposed to interact with other substances. Any atom in the bulk is not going to be exposed for a chemical interaction. On the other hand, a substance in solution is going to exist as free atoms and molecules that move freely and independently and can interact with other atoms. A solution is any homogeneous mixture of two substances or more. And in this regard, a substance that exists in larger amount is called a solvent, and the substance that exists in a smaller amount is called a solute. A soft drink, for example, is a solution which is mainly made of water as a solvent with a little bit of dissolved sugar and carbon dioxide and other coloring ingredients. Air is also a solution with nitrogen gas as the major solvent, while other gases exist smaller amounts as solutes in that gaseous solution. So a solution doesn't have to be a liquid phase. It's any homogeneous mixture in any phase, solid, liquid, or a gas. There are two types of behavior for substances when we dissolve them. The first one is the molecular dissolution. For a covalent compound like sugar, for example, when you dissolve it in water, the molecules of sugar will change from the closely packed arrangement in the solid crystal into independently moving molecules surrounded by solvent molecules. Describing the solution that takes place in this case has to take into account that the molecule stays intact in the solid phase and after it dissolves. So all what we need to represent here is just a phase as a solid with an S versus AQ for aqueous or dissolved freely moving molecules. On the other hand, when you dissolve an ionic compound, the solvent molecules will start dissociating the ions from each other. So the different positive and negative ions will be moving independently from each other. So the molecular description in this case is not very informative because it does not tell us the fact that the positive ions are independent from the negative ion. That's why we usually represent the solution, and in case of ionic compounds, with an ionic equation that accounts for the fact that ions dissociate from each other. So we dissociate the two different ions to be completely independent with respect to each other. And that is the case for any soluble ionic compound, that it will dissociate the positive ions from the negative ion. And when as we said, we indicate this with the ionic equation that separates the positive ions away from the negative ions. But in this formula, for example, we have two bromines, so we have to indicate this as a coefficient that it produces two bromide ions. This second example here, again, is going to split the positive ions as dissolved species from the negative ions as dissolved species. And again, we need to indicate that it produces two ammonium ions as indicated by the subscript in the formula here. The effect of this difference in the solution based on the nature of the substance is significant. Whenever you have a covalent compound, you will not see a dissociation at all, and what happens is a molecular dissolution. So you have covalent molecules in solution. On the other hand, when you have an ionic compound, you will see a dissociation or a splitting of the positive ion to be completely independent from the negative ion. So you actually have free ions in solution. Some substances will have partial dissociation or partial splitting, and those are specifically weak acids and bases. In this case, just part of the substance will split into the positive ions and the negative ions, while most of the substance is gonna remain molecular. So at any point of time, you will have a combination of the ionic species and the molecular species. You will have dissociated positive ions, negative ions, and undissociated molecules in the mixture of the solution. And this difference has a very significant effect on the properties. When you have molecular dissolution or no dissociation, you will have no ions in solution. So that solution will not be able to conduct electricity, because a prerequisite for conducting electricity is having ions in solution. Since we don't have ions in solution, no conductivity will be observed. And that type of solution is called a non-electrolyte. It doesn't conduct electricity at all. On the other hand, if you have a solution of an ionic compound, you will have 100% dissociation. So you will have plenty of ions in solution, which will be able to conduct electricity by freely moving the positive and negative ions. And in this case, the solution is going to be called a strong electrolyte. The third category, as we said, for those compounds that show partial dissociation, you will have a small fraction of ions. So you will have a small ability of conducting electricity, or a low conductivity in this case. And that's why we call it a weak electrolyte. And again, that's the case for weak acids and bases in solution. How can we predict what type of the solution to expect for a substance? Is going to depend on the nature of the substance. If the substance is ionic compound, that's a 100% dissociation that will convert all the substance into free ions. So that's why it's a strong electrolyte. If the substance is a covalent molecular compound, you will have two cases. The first case is for most of the covalent compounds where the dissolution is a molecular dissolution and you have no ions at all in solution. And in this case, it's going to only contain molecules in solution, and it's not going to conduct electricity. This is going to be a non-electrolyte solution. Small fraction of covalent compounds, which is namely these acids and bases, will have different situations. If it's a weak acid or a base, you will have a partial dissociation. So we'll have a combination of mostly molecules and some ions that will enable the solution to partially conduct electricity, and that's why it's a weak electrolyte. If the acid or the base is a strong one, it's gonna have a complete dissociation or splitting in solution, which means it's gonna be a strong electrolyte.